All right, everybody. This is, I'd say, the second lecture in the Machine Learning Architect series. Haven't quite called it out all like that. Maybe I'm sort of just developing it in my brain as I go, but these are the things that you need to go beyond just building a model, just knowing how to implement a machine learning algorithm, but knowing how to take these tools into a professional setting and use them well. Not just use them well, like, technically, but use them in a way that sets you up for success. So that when all your peers look at you, they'll be like, man, this person's really good at machine learning, and we want them on a project where there's going to be machine learning because they're going to help line everything up and amplify the effect of that tool. And like everything that I say, evaluation is creation. I'm a measurement first person, so I like to call myself at work. And in order to measure, you need to define what success looks like. And that's what this lecture is going to be about, is how do we take all of these measurement things that we've talked about and turn them into putting machine learning into a situation to succeed. Now, this is what we've gotten to so far in terms of our understanding how to measure. We got the ROC curves, we've got the operating points. So maybe you're working on SMS spam and you've produced a couple of models. You've been kind of got some budget to go off and prototype, so you've built these two things. You can see that your second model has greatly improved on your first model. You can go to your team and be like, guys, we can do this thing. We can solve SMS spam with machine learning. Let me have a little bit of budget and I'll go make this thing happen. Okay, but now you have to go and have a discussion with the product people and be like, well, what experience can we create? And you got to explain to them what these ROC curves mean and what, what percent of good mails get junked versus blah, blah, blah. So you have that discussion, that's fine. And they come back to you and say, well, we can't ship this if the false positive rate is any greater than 1%. They're like, oh, geez, well, 1%, what does that mean? 35% of spam is going to get into the inbox. That's, it's better than 100%, you know what I mean? Like, okay, let's ship it. I don't know, but what if you have further discussions and they say, well, come on, we want to make a product promise. We want to say we block 95% of the spam. Otherwise, we sound just sort of like silly. So now as a machine learning person, you're like, okay, that's a pretty big gap. Pretty big gap to close, depending on how long it took you to build these first two models. You may or may not, and I guess an additional ideas you have of like features you didn't try or how maybe you didn't use n-grams yet. Yeah, sure, n-grams can get me there. Or maybe we'll get some more training data, something like that. So anyway, you say, well, sure, I want to do machine learning. I'll accept this challenge. I don't know if we can do it, but I know if I achieve this model, I'm golden. I've achieved success. Total victory. I'm the best machine learning person in the world. Well, maybe. As a machine learning architect, and when I say that, let me explain it a little more. I mean, it could be, it's just like the person who is figuring out how to use machine learning in the broader system and in the product. So it could be an architect title officially. It could be something more like a program manager. It should be any senior technical person. I'd say, at Google, Microsoft, if this is the realm you're talking about, how you're using your tool, that's sort of like a senior band or maybe a level 4-ish, something like that at Google. If you want to move beyond that and get into shaping the product and shaping the strategy and shaping the vision, you're definitely going to have to move beyond this kind of approach to thinking about what success looks like for your problem. But what could go wrong? Well, maybe these aren't the right targets. And the first question you'd say is like, okay, somebody said 95%. It sounds good, 95%, I don't know, but maybe users hate it. And maybe spammers just don't care about this model. You say 95%, they're like, fine, I can run my business. You're not affecting me. And we're going to have a case study on spam filtering where we'll go through that whole thought process a lot more. But maybe, so okay, well, fine. Maybe it's the wrong thing. So let's pick a different false positive rate. Let's go to 0.05. You can have an argument. 0.05, 1, 0.05. My mother wouldn't like 0.05. My father wouldn't like 1, blah, 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 blah. And these kind of like crazy fact-free discussions are one of the real problems with setting goals, because these things are a little bit abstract. So, we're going to get through a few more technical techniques for how you can avoid having these fact-free discussions that put you in a position to fail when you start to use machine learning. The other thing that could happen is the problems could change. Spammers could start to send a lot more spam, or they could start to send a lot less spam. It might be because of something your model does, or It might be because of they went on vacation, or they need more money, or Christmas is coming, or goodness knows. And the effect of this type of thing is that maybe you have the wrong metric, because if a spammer sends 20 times more spam and you're doing it via false negative rate, then you're kind of like not sensitive to the fact that the distribution has shifted. Another thing that could happen is that you have achieved a particular false positive rate, false negative rate, but maybe all your false positives are just on things that are not acceptable to the product. Like, let's say you shut down every banking site in the world, or let's say you shut down every bicycle shop, or even there's one particular bicycle shop that used to make a living by sending legitimate messages to your customers, and you've completely shut them down. Like, there needs to be some way to deal with that. Okay, and maybe you're missing some critical subpopulations in your test data, or maybe you just haven't thought through the cost of various errors that you might have. And you need to definitely do that before settling on the false positive and false negative rate, and making sure you have the right measurements so that when you achieve it, you actually do succeed. And these last two things, nothing is more irritating as a machine learner. It's not irritating. It's like terrifying. Terrifying is a better word, is where you've created a model. You thought you achieved all your goals. You ship it. And now the product people are coming. They're filing all sorts of bugs on you. It's not working. Something's changed. You told me X and Y happened. And I think, the thing that I can recommend is that while you're talking to the other stakeholders in using machine learning in a product, make sure you walk them through this thought process, because otherwise the buck's going to stop with you, and you're going to have a bunch of bugs filed on you, like, why are there more spammers today? I don't know. Another problem is that maybe no one knows what the heck you're talking about. And there are so many different words for talking about machine learning things, and there's so much incentive for people to not seem like they don't know. So you can bamboozle people with this kind of false positive, false negative technical term stuff, and they'll be like, yeah, sure, whatever. But if they don't think through what you're really saying and what the implications are, at the end, it really is only going to hurt you. So these technical terms don't map well across all the participants. And the machine learning goals, as we'll see, really aren't tied to like, what is this product trying to do? It's not trying to do false positives. That's not what you're selling to customers in any sense of the word. So let's talk about what properties we should look for when we're trying to set the goals for machine learning. And this is probably a little bit more generic than just machine learning, but we'll just do a quick overview of some things to think about. One thing you'd like your goals to do is to communicate what you're trying to do. You don't want to have a goal that is not at least able to be related to the thing you're trying to accomplish. And it, you can have the mapping kind of implicit in your brain because you think you're a smart person and you see how things connect. But unless all participants have that kind of mapping or that understanding in their language, you'll find that things start to drift and you have very difficult conversations, and it's stressful for everyone. So yeah, you just have to look out for trying to express your goals in terms of this mysterious machine learning vocabulary that people don't really understand, but they're sort of afraid of, and they, whatever. Another thing about goals is that they be achievable and that everyone sees a path towards success. It's okay if it's difficult, but machine learning requires like new intuitions about what's easy or hard. And people who just have sort of a folk understanding of it might be like, 1% false positives. No, we need 99.99999%, or like 0.0001% false positives. Otherwise, we can never ship this thing. This is terrible. And that's not really a reality. That's somebody saying that if the machine learning person says, yes, I will achieve this, then the machine learning person is just set up for failure. And in that case, you're in a role where it's like, well, let's do machine learning for a while until everyone realizes that I can't succeed, and then go find another job and tell them I know machine learning. So maybe make it easier to get that next job. That's not what you want. So, in 1% false positive rate, 95% or 5% false negative rate, is that achievable? Possibly. And you want to make sure that everybody sees how that thing could work out. Another thing is measurable. It's very easy to make goals, things that you'd like to accomplish, but really have no way to measure them. And I'd say in general, you don't have to measure perfectly, but you need to have some sense of the benefit of progress to know if you're making progress. And again, this evaluation creation thing where if you can't tell if you're making progress, you're not making progress. And it's such a common thing. I've seen it over the years many, many, many times. One of my previous managers used to say, I want to ship a dial that can affect my system, but I'm not willing to go and build the gauge that tells me if I'm actually affecting the system in the way I want to affect it. And another simpler way that I sometimes say it is like, it's okay to invest in measurement, number one, and we're just not shipping something we can't measure. We're just not doing it. You might as well do nothing. So that's an important part of goals, is thinking through how we're going to measure this. And it's okay if you don't know exactly how to do it, but as long as you have some sense of if you're accomplishing what you want to accomplish, even if it's a fuzzy measurement, you got to be able to at least get to that point. And this is right, here's the thing that you'll bump into, is that machine learning is not just a magic tool that you sprinkle some fairy dust machine learning on a problem and it gets solved. And it boils down to this, that setting the right goals for machine learning is just about the hardest, most frustrating, and most important part of using machine learning in practice. Very, very easy to get ahead of having clear goals that all participants understand and can get behind, and skipping straight to doing something technical. My advice is don't. And let's walk through some details of why it's so darn hard to measure things. And if we're talking again about this SMS spam domain, there's three important parts. I'm going to explain them here. And one is what the world does. So there is a world out there. Your users have friends. Their friends communicate in various ways. Goodness knows. Maybe they text each other all the time. Maybe it's only on important occasions. Whatever it is, that's the reality of the universe. And then there's spammers who know about some of your users. Maybe spammers find their phone numbers so they can send them SMS through buying lists or through doing all sorts of shady spammer stuff. So more or less spammers learn about your users all the time. And that's the way the world works. Now, these people are going to be sending messages to your users. And let's say, based on the ratio, there's 100 non-spam messages per week and 1,000 spam messages per week. Maybe that's not right. Maybe it is. Whatever. Let's just go with that for this domain. Now, what you've done as a machine learning person is produce this model. So it's beautiful. What the model does is take these spam and non-spam messages and allows you to filter them, put some in the junk box, delete some, whatever it is you're going to do. But this is the knowledge you have that lets you process those and give something better for your user. So if you have this particular trade-off in your model, so the 1% false positive rate, and you achieve that goal of the 5% false negative rate, and you get into that square, be like, yes, this is our success square, we've shipped it. And the third part of this is that we have what the user actually sees. And the user doesn't see the real world, the user doesn't see the model, the user sees their inbox. That's the lens they have to whether or not your machine learning and your overall system is succeeding. So with this false positive rate and this false negative rate and this particular world, a user will see one false positive per week, and they'll see 50 spam messages in their inbox per week. That does sound kind of like a lot. And if you do like the simple math, you'd see that that means 1/3 of their inbox is spam, or their SMS inbox is spam. Take that out of the way because those words are right there. 1/3 of their inbox is spam. It sounds like a lot, 1 out of every 3 messages is spam. Your user might be saying like, man, this system is full of spam and it sucks. While the modeling person is saying, man, I just achieved this really awesome false positive, false negative trade-off. And your users are saying you're terrible. Okay, well, that's kind of the thought process of what things you need to think about when you're stacking up your measurement. And let's talk about the types of goals, the types of measurements that you could do. And here's just a quick sample of things that I drew out. You're going to have a conversation with your manager, with your program manager, with other technical people, with UX people, and they're going to say things like, hey, what we really care about is profit. Can you do machine learning to improve profit? Or we want to care that, if a new spam attack gets stopped quickly, that should be a pretty good thing. Or that users will recommend our services to our friends. So don't worry about this spam stuff. Just learn a model for sentiment of users. Or you might have somebody come up with a total cost theory, or saying, hey, we just don't want to delete messages that are really important. So can you do that? We could talk about engagement and say, hey, we want to see how many messages per month our users send, and that's what we want to try to optimize. So all this spam stuff is really just a distraction from what we're trying to accomplish. And that comes, user churn, profit, subscription revenue growth, all of these things. Okay, it's a sea of stuff. So how do you get a hold of this problem and make sure that you can put machine learning in its correct context and not get pulled off into these la la land discussions of things that you can't control. So I'm going to talk through 4 types of goals and how they relate and what you can do to have a good conversation about what types of goals machine learning should take and why those are the right goals and how they end up influencing the higher, more important properties that your organization actually might care about. And so we can do a little sort job here. But let's start in the upper left-hand corner of model properties. Now, model properties are the things that, to some degree, are exactly or close to what we've talked about measuring so far. False negative rates, false positive rates, precision, this bad false positive rate thing, which is sort of like you would have a special test set of things I really, really don't want to do wrong, and maybe measure your false positive, false negative, or precision recall on that smaller test set. You could have the costs that your model is able to achieve and how well it's able to optimize them. And you might have things about the broader training system of, hey, my model is so sensitive to new attacks that it's able to pick up things in less than 30 minutes. And that's a fantastic property of the model, that the precision on new attacks is actually quite high. So these are all things that you as a modeling person can go optimize. And these things all have really very little to do with what your organization is trying to achieve. Right. So now there's an intermediate step, which I think is very valuable. And that is the user outcome. And a model, along with the user experience, combine to achieve a particular outcome for the users. And I like to think of a user outcome as the promise the user has, like the reason they're coming to this product. What promise are we trying to give them? And this might be things like, hey, in our product, you're going to spend very little time dealing with spam in the app. Or your average inbox is going to be less than 5% spam. Or you see less spam on our site than on our competitors. That's a little bit more abstract. But another promise we might say is that you see fewer than 5 spam per week. In my day job, I work on Google Maps, and there the types of promises you might think of is, hey, we gave you an ETA. Was that ETA like kind of close to correct? Did you get there about when we said you would? And a simple promise like that might require executing 1,000 machine learning models, which may not be far off from the truth. But, all sorts of complicated things, complicated UI, user studies over time, UX, blah, blah, blah. But it comes down to that simple thing of, did you get there when we said you would or not? That's really what the user cares about. So you can see that model properties can contribute to user outcomes, but they're not in their own right user outcomes. Now, having good user outcomes over time can be very positive and can lead to success. And a leading indicator of success in a business is that our customers are behaving in the way we want. They're interacting with our system more, they're happy with those interactions, and we know that because of that, we're going to end up making profit or achieving our real goals. But maybe the real goals take longer to materialize. So we need to look at these leading indicators on a weekly basis in order to run our business. And these are things like user studies show that 80% of users think we're good at fighting spam, or users are getting more engaged with our system and are actually using it in the way we want them to use it, or users are reporting very little spam. Maybe they're having spam, but it's not bothering them, so they're not reporting it, something along those lines. And then another big one is sentiment. That is, users are happy when they use our service and they're telling their friends that, hey, go ahead and use this. And I don't know, for a while, Microsoft got into this thing called NPS, Net Promoter Score. And that's the percent of users who give you 5 stars minus the percent of users that give you 1, 2, or 3 stars, something like that. And so that would be a score. And as that score becomes positive and goes higher and higher, you have an indication that users are happy with your product. So you could see how if users are getting good outcomes over an extended period of time, you might start to see these leading indicators pick up. Not immediately. Like, you could ship a much better model today, then users start to get better outcomes, and then they start to change their attitudes, and then they start to express that they're more positive. And that could take weeks, months, who knows how long that could take. These things, user trust is a very delicate thing. You can lose it quickly, and it takes a long time to grow it back up. And then the final thing is that happy, engaged users will tend to lead to you achieving your objectives, because the users won't churn. Your user base will grow. You'll actually make more money. Your system becomes cheaper and cheaper to run. and subscription revenue grows, all those sorts of things. So now this is sort of a hierarchy of goals, the things that you as a machine learning person can control very quickly, to more and more abstract things, but then the things that the reason that somebody is paying you to sit around and do machine learning. And so this is just one way to think of how they're connecting that I found to be useful many, many, many times over my career. Now, that's nice to say at a high level, but you need to go beyond that and have some kind of technical tools, like how would you go about measuring the strengths of those connections and figuring out, because of those measurements, hey, maybe this is a place to invest, or maybe, ooh, if I go there, I'm going to be getting my machine learning systems into a rough position and I may not be able to show the success I'd want to show. So here's an example of thinking this through for SMS spam again. This is similar to what the process we used when I was at Hotmail 10, or I don't know, I think 15 years ago I started at Hotmail. And this is similar to the types of techniques we used when I joined Microsoft 15 years ago. I mean, it was a long time ago, so I'm not revealing anything that anyone's still doing. But this was a thought process for how we connected our machine learning and spam filtering to value that allowed the company to fund a team to go and work on this. So to connect model properties to user outcomes, you could say, you could do this plot and plot, well, what if we achieved various false negative rates? Now let's go look at our users, some of our users, and how they're using the system and figure out, well, how much good mail do they get? How much spam is sent to them on a regular basis? And then we can plot this relationship between the model properties and something that we might want to consider as a user outcome that we'd want to target and try to optimize and say, hey, as an organization, let's rally around this as the outcome we're trying to achieve. And that is, what percent of our average users' inbox is spam, or what percent of our users have an inbox that's more than Y% spam, something along those lines. And like that is a very powerful intermediate goal. If you can find one where all these parts line up, it's simple and it can rally people towards success. Okay, so anyway, right now you say, well, here's our current false negative rate because we achieved that. Let's say we achieved the nirvana state, or that upper left quadrant in the ROC curve. So there you go, fantastic, la-di-da. But what is this based on? It's based on the ratio of spam to good messages. It's based on how well your model is at catching them, which could vary day by day despite anything you do, just because spammers are going to be working around your system. So it's quite possible that if you do nothing, this is going to bounce all over the place, and the relationship between this and this is going to bounce all over the place. The point of this is that goals are not long-lived things. You need to constantly be investing in your goals to keep them healthy, because things outside of your control that are very relevant to choosing the right goal will change. Right, so there's a complex relationship between the model properties and the user outcomes. And if you ignore it and you don't invest to keep it fresh, you're gonna drift, and over time you're gonna be working on less and less appropriate versions of the problem you're actually trying to solve. But that said, for any planning cycle, for any decision process about what should we do for the next 3 months, or is this a good place to invest, you can look and say, well, here's the short-term gradient, the local properties, and let's assume that the world is not going to change that fast. Let's use this relationship to help us make decisions about what to do today. And you can see by looking at this chart that there's about 4 to 5 points of percent of inbox that is spam per point of false negative. And as a machine learning person with some experience looking at this problem, 95%, 1% false positive rate, I'd say, yeah, you know what? If you put a couple of good machine learning people on this, they're going to move the false negative rate maybe by 1%, maybe by 2% over the course of 3 to 6 months. Be like, wow, so we could get 5 to 10 points potentially of spam in the inbox if we just invest that. That sounds awesome. Well, is it? It's not clear yet, because so far we've only chained from model properties to user outcomes. But in order to make the right decisions about goals, you got to chain a little bit further. And that's when we got to get into leading indicators. Now, this chart here, which is totally fictional and doesn't look like any similar chart that I've ever seen, but just to illustrate the point, on this axis, you have what percent of a user's inbox is spam. And on this axis, you have the star rating that they gave to your system. Now, star rating could mean a lot of things. You got to be careful. Star rating could mean like, would you recommend this to somebody else, yes or no? Were you happy with what happened in the system yesterday? Do you think we're good at fighting spam? I mean, there's lots of ways that question can be worded, but let's just sort of abstract away from that. I'll come back to that point. So you could see that maybe there is a relationship, that users who tend to have a lot more spam in their inbox, all other things being equal, they're like, yeah, your system's not that good. Yeah, it's just not good. Yeah. But then users who have very little spam in their inbox, maybe that's the only problem your whole system has is the spam, and the UX is nice and the latency is nice and everything else is nice. And so if you could just solve this spam problem, we'd be happy. And looking at this, you could say, well, in this range of the space, there seems to be a large positive effect to improving the percent of the user's inbox that's spam. And in this place, it seems to be diminishing returns. So, in the previous, the user outcomes thing, we could connect like, hey, a certain level of investment that seems reasonable can move this number by an amount that seems large. Well, then you have to multiply that largeness by the gradient that you have at that particular point in order to decide if the investment's worth it, or if you're going to be able to declare success at some future point and get great reviews and all that fancy stuff. Okay, so there is that. Let's see what's coming up next. Right, and the star rating is affected by many things. It changes slowly. You can't expect to ship a model and move a user 5 points there and then the very next day they even notice, because these numbers are small and irritation builds up over time. And the point that I wanted to get back to is that as a machine learning person, I think it's good to hunt these relationships, but then it's also good to really scrutinize them, because the UX designers that you're working with will phrase this question according to what they think is important. And there's a very good chance that they can, there's lots of ways you could phrase these questions that breaks your ability to make this sort of relationship between variables you can control and the variables that the broader business would like to drive. So be careful, look at that stuff, and don't get sucked in or discouraged if the relationship doesn't appear immediately. Sometimes it's a lot of work to get some relationship like this that everyone cares about. But now it should be clear how to connect these, but let me just do it. So bad user outcomes with large effect on sentiment, diminishing effect of bad user outcomes on sentiment. Now, and here's false negative rate to user outcomes. And so you could say, if you're in this range of false negative rate around 5%, that puts you in this range where a little improvement could have a lot of impact on the star ratings. At this place, you'd be like, whew, yeah, let's do this investment. The stars are lining up. Let's go. Conversely, if you're already down here where your false negative rate is more like 1%, there's not much value in going further. Maybe you see a lot of technical things you could do. Maybe you want to make the case that, hey, we need to continue investing or the quality of our model will erode. But you shouldn't make the case that, hey, this could really drive our business forward and this could connect to the things that our organization really cares about. So we should have a major focus here. And if that's the case, it's not necessarily the end of the world. You could optimize other things. You could look at changing the false positive rate that you're using as an operating point. You start to connect false positives directly to user sentiment and explore other possibilities to expose places to work. You could also work on like latencies and the cost to run the overall system, or other things like how do we detune the model a little bit at this point in order to save our organization a lot of money, which might be relevant to business objectives, something along those lines. And here's an example of how you might look at putting that all together. A 1% false negative rate equals 1% false negative rate improvement could equal 4 to 5 points of percent of inbox spam, which could, in the range where we currently are, be a half a star rating for the users who you can make that change for. And then maybe people have taken it further and they've correlated star ratings with user churn, which would be the organizational objective that you would key to in this particular chaining. And then that whole thought process now puts you in a position to say, well, I know how to make a goal for machine learning. Woohoo, right? Like that's a lot of work, but not doing it is a great way to end up building something that doesn't matter and to frustrate people and to even, discourage the future use of machine learning. And why am I here? I'm teaching machine learning because I really believe in the potential of machine learning to make people's lives better. And that's why I think it's so important to spend some lecture time thinking about making these chains, because if you don't do it, please think it through. I'll just say that there's other benefits. You might come up with multiple justifications. When 15 years ago, when I was working on Hotmail, we had some super strong relationship between 1 point of spam in the inbox and the amount of money Hotmail had to spend on disks. And it was meaningful. and we basically paid for our whole team through that theory. I don't think economics works that way anymore. I think DISC is cheaper. I'm not sure though. I haven't been involved in a very, very long time. Okay, fine. So fine. We did all of that. We made that whole change, but why not just point machine learning at the thing we're trying to optimize? Why have these model properties? Let's optimize revenue. Put in some features, predict revenue. La-di-da. Okay, but let me walk you through the thought process for that, because this is something you'll probably bump into. Direct optimization of organizational goals has problems, because there is a very indirect relationship between the thing the modeling person is able to control and what the business wants to achieve. And that indirect relationship makes it very hard for a machine learning model to pluck the concept out of the features you give it and learn a good representation of the concept. And one reason for that is that a single action that you could take, like delete a message or don't delete a message, has such a small effect on the revenue of your business next month that it really is going to have a hard time showing up directly. So you need to, as a machine learning architect or a machine learning practitioner, create a simpler problem to do machine learning on, but then create all the intellectual connections to the more complex optimization the business is trying to do. But machine learning is not yet to a point where you throw it at the big problem and let it go. It's your job to curtail the problem, the sub-problem that machine learning is going to solve. And it should be like large local effects of the action. So when you get a message or don't get a message, and delete a message or don't delete a message, those effects are all very direct and large locally, like the message is in the inbox or it's not. So when you're trying to create the sub-problem for machine learning, make sure you have large local effects. Another thing is that there's a long delay for feedback, and having a gigantic delay for feedback on optimizing things like user sentiment just means that there's like, I'm going to click again and it's going to show this. Is it? Well, no. Okay, let me go. And then like versus quick feedback. And the thing is that there are so many things that can affect this complex relationship, and combined with this long delay, you really lose the focus of the signal, and machine learning has nothing left to key off of, no features that it can put weights on that are relevant, because the user experience affects it, competitors and what they do. Like a competitor launches a big ad campaign, that could change things that you have no control over and your model can't work with. Your own ad campaigns, other parts of the system may change, or the spammers may like go on vacation or double down, or like a spammer finds out a much more profitable product to sell and then they just flood your system. So all of these things are reasons that directly optimizing goals is hard. You want instead to have large local effects with quick feedback, and the context contains most of the relevant information. Like it's okay if your features or your context don't contain everything about the problem you're trying to solve, but it should contain like most things, or a pretty good representation of the things you're trying to model. And then with direct optimization, you might have like every quarter you do a sentiment reading. Well, then you get 12 training examples per year. Every quarter you can see, did it get better or not? That's not really sufficient for machine learning. What you need is many observations of the thing you're trying to model. So all of this is to say, keep these in mind when figuring out, is this a good place to put machine learning? Am I on a track to success? Am I setting machine learning up to be held accountable for something that machine learning is actually good for? And let's go through a summary of this lesson. So this is, like I said, the part 2 of essentially the machine learning architect sub-series, or the machine learning engineering sub-series. And it's incredibly important to get everyone understanding this is what machine learning can do. These are the places in the system it should go. This is the thought process that you would use before making a decision beyond just, can I model this? You should know, should I model this? And so setting goals is an important way to know that. But it's very difficult. It's very frustrating. You can talk with people for months around in circles. You're going to have to defend your thought process for what the goals are, and people are going to attack it, and it's going to be miserable. I know it's like, you would think, but no, it's not gotten easier in my career. It's a very hard thing to do, but incredibly important. Good goals communicate success in the language of everyone who needs to contribute to that success. They inspire the participants by being things that the participants think, yeah, I can accomplish that. And I could see how accomplishing that is related to the goal, the success that I'm trying to achieve. And then they're measurable. And I used even bad grammar to capitalize measurable because it's that important to me. Should be to you. I don't know. There's a hierarchy of goals that I found useful, that model properties contribute to user outcomes, and good user outcomes over time contribute to leading indicators like sentiment and engagement, and those things contribute over time to organizational success. Now, of course, in each arrow, there's a lot of work by people who aren't you to make sure those relationships hold, but I think it's your job to understand how the work that you can do in machine learning is going to line up with those people's work to potentially achieve organizational success. And this is a global, complex relationship. It's okay to not know exactly. And I think trying to set goals where you know everything exactly is one of the reasons it's so hard, because people want, it's important, but you can't always get things accurate. And you instead have to do these kind of local gradient approximations of, hey, there's 4 to 5 points between false negative and percent of spam in the inbox right now today. Let's just go with that. By the time we ship the system, that'll be different, but let's just go with that today because you got to do something. And that means you need to invest to keep your goals healthy over time. If you don't invest, eventually the problem will change and you'll be working on the wrong thing. Okay, well, I hope you enjoyed this discussion. It's a little bit outside of, hey, here's how you do the gradient of the loss function for the parameters, blah, blah, blah. But I think it's just as important, and I would say through my experience, actually more important than some of that other stuff if you want to use machine learning successfully in a professional environment. Hey, see you next time.